When graphing polar equations, sometimes it's useful to know what kind of symmetry a graph has. There are three types of symmetry we consider in the polar plane. They are symmetry with respect to the polar axis, with respect to the line theta equals pi over 2, and with respect to the pole. For symmetry with respect to the polar axis, that means whatever's happening, for instance, in the first quadrant, it's also happening in the fourth quadrant. And when I say what's happening, what I mean is if there's a point in the first quadrant, then it will also have a reflected point in the fourth quadrant. If in the first quadrant the angle that we have is theta, then in the fourth quadrant the angle that we have is negative theta. And so to test for symmetry with respect to the polar axis, we replace theta by negative theta in the original equation, simplify it, and if we end up with what we started with, then we have symmetry with respect to the polar axis. For symmetry with the line, with respect to the line theta equals pi over 2, that would mean that any point that we have in the first quadrant would be reflected in the second quadrant. And if the angle that I have in the first quadrant is theta, then that corresponds to a reference angle in the second quadrant of theta. And so that corresponds to an angle in standard position of pi minus theta. Therefore, to test for symmetry with respect to the line theta equals pi over 2, we replace theta by pi minus theta in the original equation. And if there's a sine or a cosine, then we use a difference formula for the sine or cosine. If after simplifying the equation we get what we started with, then we have symmetry with respect to the line theta equals pi over 2. For symmetry with respect to the pole, if I have a point in the first quadrant, then that's going to be reflected across the pole, and so I'll have a mirror point, if you will, in the third quadrant. If the point in the first quadrant has associated an angle theta, then that's associated with a reference angle theta in the third quadrant, but then would be associated with an angle in standard position of pi plus theta. Alternatively, the radius associated with the point in the first quadrant would be r, and then that radius associated in the third quadrant would be negative r. There are actually two tests with respect to the pole, for symmetry with respect to the pole. We would replace theta by pi plus theta, or we would replace r by negative r. In the original equation, simplify the equation. If you end up with what you started with, then you have symmetry with respect to the pole.